Hey, so you've heard about GenAI is transforming how we interact with technology today, right? So what is Cloud Run? Cloud Run is our serverless runtime platform that enables you to run and deploy your modern workload at scale. So hi, my name is Shen. I am a product manager at Google Cloud. So next 25 minutes, we're going to talk about Cloud Run and its GenAI use cases. So Cloud Run it's the fastest and the easiest way for you to run enterprise applications securely and at scale on Google Cloud without infrastructure management overhead. So when we designed the Cloud Run, we have the simplicity, automation in mind. So our goal is to get application developers to do the prototyping to production as fast as possible. And because the whole Cloud Run platform is built on the container technology, it gives your applications all the flexibility and portabilities. And Cloud Run also has great cost-saving benefits or TCO benefits. And then you only pay when your code is running. All right, so there are two main resources for Cloud Run. And then those are just kind of associated with two different type of use case category, right? So the first one is called Cloud Run Services. It's kind of more of a serving as HTTP dedicated endpoints. So it's great for if you have internal, external web applications, gRPC, HTTP-based private microservices, and the GenAI, of course, serving and orchestration. We're going to take a closer look at that in a second, and then with a demo as well. And the second type of Cloud Run resource is called jobs. So that obviously is kind of just helping you to execute tasks to completion, right? And then it's great if you have batch data processing, data pipelines that you need to take care of. Cloud Run jobs it's perfect for you. You can execute your task manually, or you can hook it up. It's actually naturally integrated with Cloud Scheduler, or you can trigger the Cloud Run jobs by events. So we have a great selection of customers in Cloud Run, and as you can see, those are some of the public reference customers, and then they cover from different verticals and different industry segments as well. And some customers, they adopt the Cloud Run, they're moving from on-prem to the cloud for modernized infrastructure. And they like Cloud Run because of its cost-saving benefits, and as well as its simple to use because there is no cluster to manage. And there are other customers, lots of them are cloud digital native customers. They love Cloud Run because of its developer velocity, right? Basically, you have your application code and you can get it up running in no time. One of the customer example, L'Oreal, global cosmetic giant L'Oreal, they've actually embraced a Cloud Run first strategy to implement the safe and secure GenAI service to its 90,000 internal employees. So they've adopted a Gemini hosted in Vertex, as well as implemented Cloud Run throughout its GenAI architecture. And they were able to launch a product called L'Oreal GPT in just 3 months. And then this is really a great showcase of how Cloud Run helps, it's a powerful tool to help customer kind of accelerate innovation and deliver a tangible business impact. Another customer, Ford, of course, everybody knows Ford, a global car manufacturing and design company, right? They've also taken a Cloud Run first approach. They have hundreds of services running on the legacy platform before, and then they actually take a Cloud Run first approach, adopted a Cloud Run throughout their services. And as a result, they were able to achieve a much more scalable and reliable platform to accelerate innovation in its vehicle design and manufacturing. They like Cloud Run because it's developer velocity, the cost saving, and also simple to use. So both customers, they have taken the stage on Google Next conference a few months ago, talk about their journey with Cloud Run. So if you're interested, I think those videos are in the YouTube website, and you can take a look.
So how does something like L'Oreal use Gemini in a Cloud Run environment? Is it an API-driven request? Is that
Yeah, exactly. So the Gemini model is hosted in it's an API model, right? So and then they implement this the L'Oreal GPT on the Cloud Run. Actually, I have a demo. Actually, will show you exactly how this is done because Cloud Run is a runtime. It's a container runtime. It's a serverless runtime platform, right? So this is where in the Cloud Run you write your code. You can call the Vertex API for your inference for your where the Vertex is going to host your large language model, and then you call Vertex AI for your embeddings, vector search, everything. So I'll show you actually in the in my demo. We'll put everything together and I will show you.
Cool.
All right, so switch the gear a little bit, talk about there are many different architectures for GenAI applications, right? And then this is just one of the RAG-capable GenAI reference architecture put up by Google. We actually have a much more detailed slides. I did not want to make it too busy eye chart. So, but there's this reference architecture that published in our website. There are three main components to this reference architecture, as you can see. Of course, number one is serving and orchestration. And then there is also the data ingestion part for RAG purpose. And then there's a quality evaluation subsystem. We're going to take a look at how Cloud Run plays a role in each of those subsystems. I'll explain those subsystems as well when I get to the Cloud Run. All right. For the serving and orchestration, of course, I mentioned the Cloud Run service as one of the key use category. It will take care of your request response flow between the GenAI app and the user, right? So that's kind of your front end. Cloud Run is great for that, right? And then, but also with Cloud Run, you'll be able to run the LangChain. It works actually seamlessly with LangChain LangServe app, for example, to orchestrate RAG, and you can use that to prepare prompts, call inference endpoints, and format responses. How we do that, I'll show you that in the code in a second. And as you can see, the Cloud Run here, it's talking to Vertex AI for the inference endpoint. It's also talking to the Cloud SQL, which is our managed database solution in the Google Cloud that actually for the vector similarity search to get the information out of there. So as I mentioned, with the Cloud Run services, it has all the flexibility to run all the popular GenAI app frameworks like LangChain, and then Cloud Run literally supports any language, any library, any framework.
You consider it a no-code, low-code solution, or real code, or all the above?
Well, so I would say Cloud Run is a runtime platform. So the code is on your own. So you have to, how you want to build your code. It's your, you worry about how you build your code. But once you have your code, how you want to deploy it with scale, take care of traffics from all different regions. And when there's no traffic running, how you want to save, you don't want to pay for when you don't. So those will be taken care of by Cloud Run. So Cloud Run is a runtime platform, helps you to run and deploy your application, if I put it that way.
You're going to point it to a container registry and say, this is the container image that I want you to use when you instantiate it.
Exactly. So I will show you. So maybe that will make it a much more tangible to a degree.
So if you're developing platforms, you can develop a low-code platform that uses Cloud Run. So it's all about, it's just a runtime of what you want to build.
I think of Cloud Run as serverless-like. It's not quite serverless, as you'll see.
It is a serverless runtime platform.
But it's not the same as, a fully serverless, function server, for example.
So people are arguing, we'll give you back your presentation. People are arguing that Cloud Run is the new service, like functions as a service was a bad idea and a bad way to wrap serverless as a concept and runtimes that you don't worry about the server, you just upload the image is serverless. That's the new term. I can't keep up with this stuff.
Well, they've got Cloud Function as well as Cloud Run, right? I mean, they support both.
Yeah, we support both, actually. Yes, functions is part of the Cloud Run as well. And actually, that will announce that in August. So we have something called the Cloud Functions. It will actually go in to be wrapped inside the Cloud Run. So with Cloud Run, you can either give Cloud Run a container image, or you can just give a piece of code or just a function. That's it. And then we will just take from there. And you have one single command, G-Cloud command line to build it. And we'll build a container image. If you don't have a Docker file, we'll actually use buildpack to, you don't even need to know about the containers, okay? And then you just give us a piece of code, we'll run that and build the image and put it in the artifact registry, and then load it to our Cloud Run runtime platform and help you scale across different regions. You specify whatever region you would like it to run. We even put HTTP endpoints on your behalf to do all this.
All right.
So it just makes your life much easier. It is based on the Knative, which then underneath is Kubernetes. But we take care of everything for you. It actually runs on the Google blog, so it has a huge amount of scalability as well. So anyway, so I know I don't have much time. I only have 25 minutes. I wish I can spend more.
Wish you had 3 hours.
I wish I had 4 hours. Yeah, exactly. So anyway,
It's just
I really want to show the demo because it will put a lot of things into the real context, and then you will see what it's look like rather than the boring slides, right? So, and then I talked about 3 subsystems in that reference architecture, right? So for data injection, why do you need a data ingestion? So that's where you want to hook up your external. So you use large language model for reasoning, right? But then you have your own data source, whether it's your customer data, your user data, you want to use that for ground and fact-checking base. So that's where we actually use Cloud Run to get those data, and then we save them to the vectors. Vectors, basically, they are numerical representation of your text and the images. And then the vector, they're great because they allow you to do the similarity search, which is basically, it's not only fast search, but also it can search by the meaning of your word, not just by the keywords. So if you want to search a happy dog, it will actually return something like a dog wagging its tail. So it's really powerful tool there. So the data ingestion help you to prepare your data so you can actually augment your large language model for ground and fact checking basis. And the Cloud Run job will work with the Vertex Vertex embeddings API, and then help you convert those data into the vector database in the Cloud SQL. So this is how
you're showing pub sub there. Is Cloud Run providing that orchestration to drive pub sub from the data cloud storage? So as storage shows up, I can have it come in and do the database and do the embedding and all that stuff automatically.
Exactly. So whenever you have, so ideally you have all your data in the storage and you do the job, run the job once, and then you convert everything in the vector database. But then as you add in new data, which in my demo I'll show you, because then I have new features released or new data gets added to the storage, right? That events get triggered by PubSub, and then we'll tell the Cloud Run to do that. Or you could alternatively, you don't even need a PubSub. You can put up a Cloud Scheduler, which is fully integrated with Cloud Run. Say, I'm going to run this job periodic base every day or every week or whatever frequency, and then it will be able to always get the latest data to your vector database. So when you run your GenAI app, will always have the up-to-date information based on the data you have, right? And then, of course, for the quality evaluation, this is basically another thing for the GenAI app. You want to make sure your GenAI app does not degrade over the time. And then so you want to have a set of golden prompt, which you load into, you test your GenAI app on a periodic basis. So kind of you do the quality evaluation that, and of course, Cloud Run job is perfect, right? You can run that on a periodic basis to evaluate your golden prompt. Anyway, all right. So let's get to the demo. I'm going to sit down for this demo. I still have a few more slides to explain this demo. So this is basically, we're building a LangChain-based app with Gemini, and we're going to deploy it to Cloud Run, right? So this is a pretty simple demo. We're going to say, this is basically, it's a web-based application that you query all the supported feature on Cloud Run. And then we're going to use the Cloud Run release notes, which is public, to augment this particular large language model so that it will give you more accurate, give us more accurate result, right? So how do we do that? I'm going to break this down app into we're going to take two-step approach to build this app, right? So the first step is actually, this is the data ingestion step that I talked about. So this is where you use Cloud Run jobs to import the release nodes to a vector database. And then I have my release node in the BigQuery. You're going to see the code in a second. And then I will call the Vertex AI to do the conversion, save, and then convert those to the vector embeddings and save them into the Cloud vector database with the PG vector extension there. And then, then I get everything, all the release nodes prepared in my vector database. So let me show you. This code. So this is basically it's a small piece of code. It's an index of Python. I have everything actually fully step-by-step lab online, and you guys, if you're interested, you can follow as well. So here first we import a bunch of libraries, right, and a very simple step, and then we retrieve all the Cloud Run release nodes from BigQuery. We store those release nodes in our BigQuery. So we kind of initialize and try to retrieve them. And then next step, we're going to just set up a PG vector instance and connect to my Cloud SQL database. You can see all my past try to access the Cloud SQL database there, right? And set up the PG vector there. And then the next step, you can see I specify I'm going to use call the Vertex AI embeddings. This is where and I'm going to use this particular model called Gecko text embeddings model to do the conversion. So this is a great model in Vertex AI that helps me to convert the release node into this thing. And then once I'm done, I will say, hey, done serving, and then how many release nodes do I get? So this is a piece of Python code, right? And then how do you get this to the Cloud Run? It's actually very straightforward. We don't have time to run this. All you need to do is just run this one single command to deploy this in the Cloud Run. So literally what this command does is that it's going to take that index of Python code and compile it, build a container image, and put it in the Google Cloud, use Google Cloud Build and put it in our artifact registry, and then it's going to execute that job, because I said execute. Now you can also say execute every day, every week, or whatever you want, right? So I'll show you what this look like. So then if I go to my Cloud Run console, you're going to see this is a job, the index job, right? So to save time, because it takes a few minutes to build, so I don't want to waste any time. So I built it. You can see this early this morning. Yeah. So this thing, and you can see the log to prove that. So you can see that this job is run, and then we retrieved like 202 release nodes from the public library, and then from the BigQuery, and then we done saving those in the vector database. If we have time, we can go to Cloud SQL to take a look at those the vector database, but we don't have time, and we're going to focus on this app. Okay, so now we've done the first step of doing this data ingestion. We prepare the data, right? So now the second step is to building the main application. So for this main application, we're going to also use LangChain. So, but anyway, so the application, what it does is that you take the user query. The first step, I'm going to send it to the retriever. A retriever, what this does is that it will take my query and then go to my vector database to do a similarity search to find anything similar to my query. Right, that database we just built. And then it will take the original query and then the result from the similarity search to the prompt template. And then we're going to construct a prompt. And after we construct the prompt, we're going to send that prompt to the large language model. And then after that, we're going to format the response and send back to the user. So, and for those steps, we're going to use a LangChain chain. To do that, let's take a look at the code. So basically, the LangChain LangServe, it's a really great tool because it gives you a very nice playground where you can actually send a prompt and examine your result and even the intermediate result of your this whole process. And I'll show you what it looks like. But before I even show you the code, I use in my environment, I use the LangChain command called LangChain app create new to create a base folder. So LangChain will create a base file folder for me, and then it has all the base file for you to run the whole LangServe app. And then all I need to do, so it actually give me this run rag app and then it give me some of the files with the packages and all this Docker file comes in with it. I don't need to change any of the things, file. All I need to do is to customize this particular file called a server.python file, put in my main logic that I just talked about. So again, in this file, we import a bunch of libraries like PG connectors, vector extension, and then Vertex AI, all these different connectors, right? And then the next step, of course, we're going to initialize.
The code.
Oh, sorry. Thank you for. I got too excited. I just want to save some time for Brandon to present. He's waiting patiently online to talk about the exciting GK. He has exciting, more complicated demo than mine. All right, so the few steps to accomplish what we just talked about. Of course, again, we have to initialize the vector store because we're going to use this access the vector database again, and we also need to kind of convert the user query to the vector embedding so we can do the similarity search. This is where you see this vector Vertex AI embeddings model gets called again, right? So if I put in a query and then I'm going to retrieve the similar release notes based on the query I put in. This is where I'm building this retriever part of the code, right? So and then it does all the magic there. And then the third step is that I'm going to then take the original user query and then the retrieved information from that release notes, and I'm going to create a prompt template out of it. And then the prompt template here say, hey, you are Gemini, you are a Cloud Run expert. You're going to answer those questions, and then you use the retrieved release notes to help answer the questions. This is what we give the guidance so that it doesn't diverge from that, right? And then the fourth step, we're going to initialize the large language model. As you can see, we're calling that endpoints where the API hosted in the Vertex AI, like Cloud Run doesn't host that endpoint, right? So here we specify the Gemini is my model, and then we set the temperature to be very low because we don't want it to be creative. This is more of a technical app. So, and then we're going to use LangChain to chain everything together. And then that's it. So this is the app. And then again, with this app, we are going to use that pretty simple, straightforward command to build it, and we're going to deploy it. In this case, it's going to be deployed as a service because it's a web UI-based application, right? So this is a pretty straightforward. It's going to take that code. Of course, now there's a Docker file. We'll build a container image out of it, and it's going to deploy to the Cloud Run as a service. So let's take a look at how this looks like.
How these release notes are complex in terms of type of text. That's just the plain text.
It just just like any product release notes. So
Right.
saying on this date we release this feature, what this feature is about. On this date,
like tables or anything like.
Yeah, it's all text.
It's all
so
text. Cool.
So now let's actually take a look at the actual so we go back to Cloud Run, and then this is a service, right? So the nice thing about Cloud Run is that, so let's say I execute that command. The nice thing about Cloud Run is that it gives you this automatic URL. Of course, if you want your customer domain, you can do that easily as well. But and then if you don't have traffic, you scale down to 0, and then if you do. So if I click on that URL, it will take you to the app we just built. So let me share the tab. So this is the LangServe app that we just built, right? So let's say does Cloud Run support, I don't know, direct VPC egress? Okay, let's say maybe so when. So yeah, so this app comes back, say, yes, it does support direct VPC, and then this is the date. So obviously this is it definitely used the information that we supplied to the large language model. And the nice thing about the LangServe app is that it gives you all the intermediate step for you to debug as well. Because if you remember the Chen that we have multiple sequence and the steps, right? And it will
Would you
give
ask
you.
it now to explain what VPC egress is?
Sorry. Yeah. So VPC egress is really just allow you to allow Cloud Run to connect to, for
I
example.
understand. I mean, can you ask it to explain it?
Is that
For
the
this
AI you
app,
built?
no.
Is that the AI you built? Because if not, then no.
No,
Yeah.
no.
That's-
I
What do
just
you
want
mean?
to
If you
ask the
guys-
information. So let me show you.
It's not in the release note.
Exactly.
Right?
So-
This is only giving us returns from the release note.
Okay, let's say, does Cloud Run,
You told it not to.
Yeah.
we can actually ask that question. Does Cloud Run, let's say, helps me run faster?
Huh.
Oh, sorry, where is that stop button? It's not a very pretty thing. It doesn't answer. So we can say, can you explain?
That's how you set the context.
Yeah.
And you were, it was in the
Yeah,
prompt, like in
Yeah,
the code,
I
where
see.
you said like basically,
Yeah.
if you don't know, don't try to
Yeah.
made it up. Yeah.
yeah.
And you set the temperature really low. So
Exactly. So it's not going to get too creative. Can you explain Cloud Run?
Yeah. You can
direct-
obviously set the temperature
Yeah,
higher and
leave
say
the
like, feel free to make up any answers.
Yeah, I don't even
Yeah,
know
you
how
don't
this
want
is
that.
going to come out.
This is factual.
Oh, actually, it does explain a little bit. So maybe in the release note, it does have a
Yeah.
very brief explanation of what this feature is. That's why it comes up. This is thanks to that similarity search.
Yeah.
So also the Gemini is also quite intelligent, right? So we use it for reasoning. So anyway, so yeah, so this is this all I have. I think
So Lisa, you're demonstrating Cloud Run here
yes.
using your own app that you create, your own AI service that you created.
Mm-hmm.
And what you're showing us here is not the beauty of that AI service exactly so much as the fact that you're just going to go and put a bunch of code in and design it well, and it'll run.
I want to show you how simple it
She
is to.
fired up an application with 2 Python modules that read all the release notes, understood all the release notes, and was able to answer any question about all the release notes that ever came out about Cloud Run in 20 seconds. I don't know.
Yeah, the key thing is that once
Thank you.
have the code, thank you, you guys summarize much better. Once you have the code, it's just very easy. It takes you 5 minutes to build it and then run it and get to the production. If you want to scale
And in
this,
production, like you,
Yeah.
you can expose this to 100 test users
exactly.
around the world
1,000 or 10,000.
by sending them the URL.
Yeah, exactly.
Bam.
And then you can also do all the traffic splitting revision. And then if you have multiple things, so I just don't have time to showcase.
And you don't need Ray or Alistair sitting there making sure that it happens. It's just going to happen. You guys
Yeah.
are now irrelevant.
Thank
Yeah, one single
I'm
command.
writing that Python code.
Well, welcome to my world.
I've been waiting to say that all day. So,
All right.
For example,
Yeah.
if one of these companies like Ford had a database of customer queries,
Yeah.
they could feed that in and then use
Yes.
that to handle future customer queries.
Absolutely. So that's, I think, a lot of those companies, they're trying to use large language model to build and augment it with their own data to build.
Yeah. Then your biggest challenge is actually the data you're feeding it in, right?
Yeah.
It's like, it's almost like if you have rubbish data, that's the answers, right? Like, so then the answers can like varies like between the agents. So
Yeah.
that's
And you could take the same structure and point it to anything, any data you want, any database you want. You could point it to Wikipedia and ask the same questions of Wikipedia, and it would just take longer and it'd be a bigger RAG database. But effectively, this structure works for just about anything.
I agree. Yeah.
Because
Yeah,
And
and
Reg-
it has that guardrail that you built in it too, because the famous case of the airline where they have to refund this ticket because the Chat GPT said they could get their refund for the ticket they were buying at the last minute, even though that was against policy. You have the guardrail in there. You could read the airline policy, and you say
Absolutely.
if it's not in the policy, just say you don't know.
Yeah. That's a
And
great.
so you protect it against that
Yeah.
type
Yeah.
of thing in a Python module that anyone on the automation team can run.
Yeah, absolutely. Absolutely.
And Lisa, how like complex it would be to use the Cloud Run for fine tuning?
Oh, so for fine tuning, model fine tuning, I think I would recommend you to use Vertex or GKE. So
Okay.
yeah, so you just run. I think this is mainly for Cloud Run. It's for the serving, orchestrating, and then we actually will be supporting GPU soon. But it's just a very basic inference thing. So for your model,
The web app.
yeah.
Web app.
And then what kind of restrictions are in place within the Cloud Run instance to kind of prevent pricing going out of control, having that $1 million bill come in?
Yeah, absolutely.
Inefficiencies in your code.
Yeah, you definitely will be able to specify, I think, the number of instances that, like a concurrency and a number, there's a quota set you can set as well too. So there are different ways that you can actually make sure your control, you don't go out of control. Like, but the thing is that if this is for web serving, if this is for serving a web application, if you have a lot of traffic, if you want to limit that, do you want to limit that or not?
Yeah,
It's a new way to make users unhappy.
Yeah, it would depend on what your goal is for it.
Yeah,
but
you
it's
could potentially there's some thing you could configure to.
You'd wrap this up an API gateway and then use the API gateway as you can.
Yeah, you can use exactly. That's another way.
Did you
There's
say
a
that
different
Cloud
ways.
Run only works with CPU inferencing at this point? Does not work with GPU or TPU?
So right now, Cloud Run only supports CPU, but we will be supporting L4 GPU pretty soon.
But
Oh,
We're going to have
Yeah.
L4, yeah. So
But
it's
you
only for inference purpose.
Right.
Yeah.
but you can still very much call Vertex. You can call
Yeah,
any
you call
Google
Vertex,
You
exactly,
can
yeah.
call any Google service that uses GPUs on the
Yeah.
back end.
You can call GKE. For example, you use GKE for your which Brandon is going to.
When you called Vertex to answer the prompt, the inferencing wasn't being done by Cloud Run; it was being done by Vertex.
Either
You
GKE.
generated the prompt and all that through the RAG and all that stuff, but at that point you send it all to Vertex.
Yeah.
All
Heavy
of it.
lifting is done by the Vertex or GKE.
Yes.
So the whole model, fine tuning, the model training thing happens in either GKE or Vertex, whichever way you want to do it. For example, I think Brandon is waiting patiently online, but he is actually, he will probably show you JAMA runs on GKE. That's where all the action happens. And then once that model is ready, and then we can call that model via the API to serve the user. I hope that makes sense.